complex numbers. So complex number has the form, we use Z, that's what we use, where it's A plus BI, where A and B exist in reals. That means something like this, 5 plus 3i, this is a complex number, or 3.1i, or this Oxford split. And so where A is what we call the real part and B is the imaginary part, it's important to note that the imaginary part does not include I. So the imaginary part, let's be very clear about this. Let's be very clear about this. So here, the real part of this is 5. So we just usually say RE, the real part is 5. The imaginary is usually IM, and this is just 3. So here, the real part is 5, the imaginary part is 3. For here, the real part is 0. The imaginary part is 3.1. And here, the real part is 3/2. This is the real part. And the imaginary part is, well, 2 over 2, of course, is just 1. And so, where I squared is equal to -1. So here we have this, what we call the imaginary unit. We call this I. This is more proper to say I squared is equal to -1 than I is equal to the square root of -1. Though the reason that this is more proper to say than this is super complex and you guys don't need to care about it. So most of the time, just say the imaginary unit of I is equal to the square root of -1. And so we introduce this in order to do solve equations. That's why we introduce it. And so here, this is what you guys are going to use for the imaginary unit most of the time. This is what I know it to be, because I know it to be a more proper form to do that, because technically this is disallowed, but I can say that something squared is -1. I can declare that. Don't worry about it. All right, so when we're adding, so let's go through this. I'll do 2 of them with you. I'll have you guys do C. So if you're adding negative numbers or subtracting negative numbers, you just add up the real part. So here, if I'm adding this real number, or this imaginary number plus this imaginary number, I just add up the reals, A plus C. And that's my new real part. And then I add up my imaginary parts, which is B plus C, and that's my imaginary part. And so just kind of think of I as an X, as some variable. So we add the non-variable parts and the variable parts together. And we subtract the non-variable parts and the variable parts together. So we keep the imaginary unit with it. So if I was going to perform this operation, it'd be 2 plus 6, which give me 8, plus 3 minus 3. Well, 3 minus 3 is 0, so this is just 8. And this one just ends up being 8. Here, if I was going to do this operation, I need to move in my negative sign. So here I have 3 minus, or -3 minus, so it'll become plus 3i. Then I move in the negative, this will be plus 2 minus 4i. Yeah, I know, you probably need. And so when I do this, -3 plus 2 will give me -1. And this 3 plus -4 gives me -i. Okay, so go ahead and try C.
You need to go out. I'm going to send you out.
So try C real quick. Let me go take this out. Come on, you. Let's go potty real quick. All right, so we got answers to C. So let's go through it. So here, where are my real parts? My real parts are here and here. So I have 3 plus 6, which gives me 9. Okay. Then I have my imaginary parts, which is 7 minus 2 plus 2. Well, the minus 2 and the plus 2 just cancel, so I just get plus 7i. Okay. Not sure which comes first. Usually, if you write it either way, it is technically correct, but often you write the real plus the imaginary. It's usually a plus bi. Okay. All right, so let's talk about powers of I. So here we have a power of I. So I to the first power is just itself, right? I to anything. Here, this is our definition. I squared is our definition. I to the third would be I. So here, I to the third is the same thing as I times I squared, right? Well, I squared is -1, and so it'd be -1 times I, which gives me minus I. I to the fourth would just be I squared times I squared. Well, I squared times I squared is -1 times -1, which gives me +1. Then when I get to I to the fifth, we can just write I to the fourth plus I to the first, right? So I to the fourth is 1 times 1. And then I to the sixth is -1. And so it actually just keeps following this. So I to the seventh would be minus I to the eighth will be 1. And so it just cycles through I minus 1, -I, 1. I minus 1, -I, 1. Just on and on and on and on and on. And so some of your homework will just ask you to simplify. So if I follow this pattern, what is I to the ninth? I'm getting a drink real quick. Yeah, it should be I. Because it goes I, -1, -I, 1. I, -1, I, -1. So this is just I, and you can just kind of get to this. But once I get here, and I to the 0, let me just do this real quick. I to the 0 is just 1, right? Because I'm going backwards, right? And so if I went backwards, 1, -I, 1, I, it'd be 0, or anything to 0 power is 1. What about I to the 47th? Well, notice that every time this cycles every 4, right? So I can take 47 and I can divide it by 4. And I'll get 1 here. Gives me a 4. That drops down to be a 0. And then I get, we'll put a 2 here. This will be, nope, I can't get a 2 here. This will be 1. This give me a 4. Or so this drops down to 7 minus the 4 gives me 3. So 11 remainder 3. This is what we care about, remainder 3. Because here I can write this as I to the 4th to the 11th power times I to the 3rd. Well, I to the 4th is just 1. 1 to the 11th power is 1. And so here we have I to the 3rd. I to the 3rd is minus I. I might have done that a little bit too fast, but let me explain how to do this with something a little bit, let's just be a little bit more, let's say 102. If I take so I to the 102th power, let's just do a couple of these so you get more comfortable with this. I to 102 power, if I take 102 and divide it by 4, what's my remainder? What's my remainder for 102 divided by 4? What is 102 divided by 4? Not square root, but divided by, oh, I'm on the wrong layer. Divided by 4. What's my remainder? 2, right? And so 2. And so I to the 102 is the same thing as I to the 2. And so you just find whatever the remainder is, and then you just look at your little list. This is -1. So if I had 445, if I divide that by 4, what do I get? Well, it'd be 0, 0, 1. So my remainder here is 1. And so this is, so I to the 445th power is the same thing as I to the first power, which is equal to I, right? And so the way to do these is you just take your your exponent divide by 4, whatever the remainder is. If it's remainder 1, it'll be, remainder 1 here, remainder 2 here, remainder 3 here, or remainder 0, which would be 1, right? And so that's how you do those. It's just, I don't know, a fun little trick you can use to deal with any size of i's. And so just do a couple. It'll come together. Let me have you guys try one without me real quick. So I to the, let's not make it terrible. Let's just say the 63rd power. What is I to the 63rd power? See if you guys can figure it out. So you take 63, divide by 4, find its remainder, and then use this up top. Let me open up something as you guys do that. All right, so we have 1 vote for -1. Do we have any other votes? We have 2 votes for -1. I mean, not -1, negative I, sorry. That's an I, thank you. So yeah, it's minus I. And how we do this? Well, 63 divided by, 63 divided by 4, that's a 1. 4, minus that out, I get 2, 23. 23, we put in a 5, I get minus 20. Remainder 3, so remainder 3 is this right here. So this is just minus I. Okay, so that's how you do it. It's just, what's the answer for B? The answer for B is minus I. Okay. All right. So let's do some multiplication. All right, so when we perform multiplication, here we just FOIL like we always do. First times the first, the outside, inside, and then last. But notice when we do this, that I squared is equal to -1, so we just make this negative. Okay. But you know, I really don't memorize this formula. I just multiply and then just use my powers of I. So let's just go ahead and do this. So we're gonna FOIL this. And so what do I get? I get 2 times 6. Let's go back in. So 2 times 6 is, my brain will fire, 12, right? 2 times -3 will be plus minus 6i plus 6 times +3, which will give me plus 18i. And then this times this will give me minus 9i squared. So here I'm just FOILing 2 times 6, 12. 2 times -3, minus 6i, or minus 3i will be minus 6i. 3i times 6 will give me 18i, minus 3i times minus 3i will give us minus 9i squared. So let's just simplify this. So we have 12. Remember, I squared is equal to -1. So this becomes plus 9. And then this will be plus 18 minus 6i. I move everything together, and then I just simplify. This will be 21. 18 minus 6 becomes positive 12i. Okay. All right, so I'm going to do C. So let's do C. So here I have this cube, so it'll be 2 minus 3i, 2 minus 3i, 2 minus 3i. So just do that. So let's do these first two together. So it'll be 2 times 2 will give me positive 4. This will give me minus 6i. This will also give me minus 6i. And then lastly, I have negative 3 times this would be plus 9i squared. I simplify this. This becomes positive. This becomes negative because remember this becomes negative. So 4 minus 9 will give me minus 5. And this will be minus 6i. Minus 6i will be minus 12i. Okay. Minus 3i. And so here, go ahead and try to finish this. So I've done 2 of these. So go ahead and try to finish this real quick. So tell me what the answer to C is. And then if you have time, do B. I'm going to go. Oh, someone finished already. All right, let's give someone else a chance to try real quick. All right, so we only have 1 person so far. Oh, we got 2. We got 3. Okay, well, that's the right answer. So let's go through the process. So here we'll have negative 5 times 2, which gives us minus 10. We'll have negative 5 times minus 3i, which gives us positive 15i. We'll have negative 12i times the 2 would be minus 24i. And then we'll have negative 12i times negative 3, which gives us plus 36i squared. And so remember, I squared just becomes negative 1. So it'll be negative 10 times negative 36 would give us minus 46. And then we'll have 24, negative 24 plus 15 will be minus 9i. And that's our answer. Okay. Here, we don't always have to FOIL. Sometimes we can just move into 3i. So here, this become 3i times negative 3 just gives us minus 9i, and then 3i times plus 12i squared. Well, I squared is negative 1, so it'll be minus 12 minus 9i. And so that's how we can compute that. And so here, this is how you perform all the operations. I have someone ask a question, negative 5? Where'd you get, where are you confused with the negative 5s at, Tyler? Never mind. Okay, we're all good. So here we have complex conjugates. Dogs. Hey, come here. Come here, you two. Eat this, not each other. Here you go. All right. So here we have complex conjugates. So here, so if z is equal to a plus bi, the complex conjugate has a little bar in it. So z bar is what we say, how we say that is a minus bi. And the reason is it gets rid of, if we multiply the two together, we get rid of our imaginary unit. Because here I have a plus bi times a minus bi, well, I get a squared, and then I'll have abi minus abi plus abi, which will cancel each other out. And then minus bi squared, which is the same thing as plus b squared. And so we use this to solve a lot of things. And then when we solve problems, we're going to get answers as conjugates of each other. So here we just want to find the conjugate. And so here we're just going to write it out. So z bar is the same real value, except I'm going to negate the imaginary unit. All right, so it was negative before, I'll make it positive this time. And for this one, since there is no real part, we just negate the imaginary part. So what is the answer for B, real quick? What's the answer for B? So what's the answer? Close. So here, what's the complex conjugate for this? So here, notice what we do is we just negate the imaginary part. So it'll be 3 minus 4i. Yep, that's it. So all we have to do to find the complex conjugate is just find out what the imaginary part and negate it. I'm pretty sure your computer will probably do something fun like this where it's like minus 7 I plus 10. And as for the conjugate, here you just have to notice that if this was z, then z bar would be 7i plus 10. And so it's not always just the second term, it's just whatever the imaginary unit is. So I'm pretty sure your computer will play fun games like this. It may not. I could be wrong. But I think I remember it did. I don't remember. So that's just what a complex conjugate is. All right, so let's do the last page right here. All right, so this is where stuff gets a little bit more fun, interesting. Let me rewrite that. Not fun, but complicated. But we say fun just to make life sound better. All right, so if we're going to divide by complex numbers, so if we want to, if we're doing dividing by complex numbers and we want to figure out what the real value is and what the imaginary value is, we don't want any imaginary units on the bottom. So if I'm dividing two real numbers, so a plus b and a plus bi and c plus di, if I'm dividing those, I'm going to multiply the bottom here by the complex conjugate of the bottom part. So here I'm going to negate it, multiply it. And this. So here you can use this huge formula, but that's not necessary. All you remember is that no matter what's here, we multiply by its conjugate. So here, in order to perform this operation, I'm going to multiply by its conjugate. So it'll be 1 plus I. And then here will be 1 plus 2i. Okay. Let me zoom on in so my handwriting is a little bit better. All right, so on the bottom, if I multiply by the conjugate, I'm always going to get a squared plus b squared. So this is going to become 1 squared plus 2 squared, just what it becomes. Now, can you do this longhand? Sure, you'll get the same answer. Now, what's on top? So we'll have 3 times 1, which gives me 3. 3 times 6, 2i gives me 6i. 5 times 1i gives me, or 5i times 1 gives me 5i. 5i times 2i gives me plus 10i squared. So let's go ahead and combine some stuff. 1 squared plus 2 squared is 5. Here, this becomes minus 1. So I'll have 10, negative 10 plus 3, which would be minus 7. We'll have 5 plus 6, which gives us 11i. And then to split it apart, we'll have minus 7 fifths plus 11 fifths I. And this is probably what your computer will want you to get you to. That way you have the real part, which is negative 7 fifths. We'll have the imaginary part, which is 11 fifths, and I. All right, for this one, of course, the imaginary unit here is the conjugate here is minus 4i. So we're going to multiply both sides by minus 4i. And so we just multiply by this conjugate. And since there is no real part, we just negate the imaginary part. So what do I have on top? I'll have minus 28i plus, or minus 12i squared. And then this just becomes negative 16i squared. And so minus 16i squared, Well, this just becomes 16 because I squared becomes -1. So we make this positive. And so here I'll have minus 28i minus, or plus 12 all over 16. And then I can just divide out the 4. Actually write this as 12 16ths plus, or minus 28, no, 2, 8 16th I. And this is correct, or we could simplify this. 12 16ths is the same thing as 3/4. 28 16ths is the same thing as minus 7/4 I. And so how do we do this? We multiply by the conjugate. This will give us a squared plus b squared. So notice here, this would be 1 plus 2 squared, which is 5. Here we have no a, so 0 squared plus 4 squared is 16. And then we just do the normal multiplication as we did before up top. All right. Please do practice a couple of these and do the homework. That's kind of, some of the stuff seems fairly new. I don't know how many of you have seen complex numbers before. How many people have played and done complex numbers for as an informal survey? You've seen it a little bit, you haven't seen it at all. I just like to know where you guys are at when it comes to this. I've seen it a little bit. I've seen a little. Okay, so most of you are about never in my life. Fair enough. But it's been a challenge. Okay. But I don't understand it. Okay, that's fine. So I just want to know where you guys are at. And so in my mind, the best way to handle complex numbers is treat I as a variable and then use this right here. Then use this right here. So if it's I, just leave it as I. If it's I squared, just convert it to a -1 and so forth, right? So just treat it as a variable and kind of live life that way for now. That's the best way I would do it in your mind. So just think, if you see I, just think of it just as like an X or a Y or an H, right? Just treat it as a variable for now, with like the one little caveat that I squared is equal to -1. Okay. All right, so why do we do this? So we do this so we can do roots of negative numbers. And I want to be very, very clear on some things. See, I can say this correctly. If I have a negative, so the whole point of this is so if I have a negative underneath the radical, I can make the radical positive, and I can pull out that negative as an I, right? I can pull out that -1 as an I. And so here, I'm going to do this as slow as possible. So this square root of -2 is the same thing as I square root 2. And this square root of -3 is the same thing as I square root 3. And then I can multiply the two together. So I'll get square root 2 times square root 3 times I squared. Well, square root 2 times square root 3 is the same thing as square root of 6, if you remember your radical rules. Because you can multiply what's underneath the radical. And then here, I squared is just negative. So we get that. Do not, all right, let me do this in red. Do not multiply negatives there. Oops, that's not what I wanted. Negatives under the radical. And what I mean by that, don't take -2 multiplied by -3, you're going to get +6. And notice here the correct answer is minus square root of 6, not square root of 6. And so you have to be very, very, very careful with that. All right, let's do one more. Let's do this one. I'll work through it with you. Let's get off the do not do red. And so the first thing I want to do is pull out all my i's. So here, can I pull something out of here? Can I simplify this? The square root of 12, can I simplify square root of 12 by itself? Does anyone know? Because I can write this as the square root of 4 times the square root of 3. which is equal to the square root of 4 times the square root of 3, which is equal to 2 square root of 3. You guys seen where you can pull out perfect squares before? I think we've gone over it and I've listed them once. And so here, I'm going to write this as 2 square root of 3 minus, and then here I'm going to pull out my I square root of 3. So I have this plus 3 plus I square root of 4. So what did I do here? I'm just invoking this simple rule. Is I pull out I for all my negative numbers. And then I'm just going to multiply across. But notice here, I have a square root of 3 and a square root of 3. And just to make my life easier, I'm going to pull the square root of 3 out. So this will be 2 minus I, 3 plus, what's the square root of 4? Well, it's 2, right? So 2I. And so now, once I've done this, it's just simple multiplication of complex numbers. I don't know if that's simple, but it simplifies down to multiplication of complex numbers. So it'll be 2 times 3, which gives me, so I'll carry my square root of 3. It'll be 6. So plus 4I minus 3I, and then minus an I times negative 2, so it'll be minus 2I squared. And we simplify that down one more time. I'll have square root of 3. 6, this becomes a negative 1, so it'll be plus 2, so it'll be 8. Plus 4 minus 3 would be 1I, which is just equal to 8 square root of 3 plus square root of 3I. Okay. So why do we do this? The reason we do all this is so we can solve stuff that looks like this. We want to solve this, but this doesn't have any real answers, as we've shown before, because here I'll have x squared equal to minus 4. I move the 4 to both sides. If I take the square root of both sides, I'll get x equal to plus or minus the square root of minus 4. Well, now we can solve it. So we'll have x equal to plus or minus I square root of 4, which is the same thing as plus or minus 2I. And so here we found the imaginary answers to this problem. Sometimes when we put stuff in the quadratic equation, so here this doesn't factor, so we have minus 4, so negative b plus or minus b squared minus 4a, which is 1, c, which in this case is 5, all over 2, a, which in this case is 1. That simplifies down to minus 4 plus or minus square root of negative 4 all over 2. So this becomes 16 minus 20, which gives me minus 4. Well, here I can rewrite this as minus 4 plus or minus I square root 4 over 2, or negative 4 plus or minus 2I over 2, which is just the same as negative 2 plus or minus I. And here, once again, we can solve this. Now these two